Hi, this video will show an overview of the BreatHere system. First off, I'd like to present the legend. The green parts are commercial off-the-shelves parts, and the yellow parts are custom components. The solid lines are oil lines, and the dotted lines are electrical wiring. The sensor and the control monitoring system have a different shape as well. The first part of the system is the air connections. We can use the system with medical air and oxygen that's coming from the hospital wall. This system will be connected to a flow meter and an oxygen blender. In the case of our system, the gas mixer provides two regulators and a way to blend the oxygen according to a chart. After that, the air continues in the system. All excess pressure that's set above the inspiratory pressure or the PIP pressure will go through the water column regulator and will be vented in the room through an HEPA filter. Meanwhile, the pressure that's remaining in the system, which is the PIP pressure, let's say for example 40 cm of H2O, will go to the anesthesia bag that allows us to have a small air reserve that's able to smooth out the variation in pressure in the system. When the intake valve is given the signal to open, the air will go through the system. The intake valve is controlled by our control system, which is composed of timers, solid-state relays, and a pressure sensor. All of the control system is powered by our power supply, which is also powered by a UPS that allows us to have at least 3 hours of power if there is a power outage. Once the intake valve is open, the air goes through a check valve to prevent rebreathing. It then goes to a disposable patient tubing, which is compatible with heated humidifier, which then goes to the patient. The HEPA filter here and the blow-off valve here are safety features. The HEPA filters that are at the intake and the outtake of the blow-off valve are meant to prevent contamination. Meanwhile, this is a safety column, which means that if the patient coughs and the pressure in the system goes over 40 centimeters of H2O, the excess pressure will be vented here. At the same time, if there is a mistake in the operating system and that the air at the intake is higher than 40 centimeters of H2O, all that excess pressure will be vented off. After being in the patient, the air will go through the disposable patient tubing exhaust, which will then go through another HEPA filter to prevent contamination. After that, there's a pressure sensor. That pressure sensor detects a high pressure, a low pressure, and when the patient tries to trigger an inspiration. If the pressure drops, indicating that there is an inspiration trying to be taken by the patient at the set level, the pressure sensor will send a signal to the control system. The flow sensor here will detect the minute volume, the expiratory volume, and the respiratory rate, and related alarms. All that information will go in the non-critical monitoring system. That system handles a few alarms, but does not handle the life of the patient, which means that if the system crashes, or if the connection with the monitor, in this case the tablet, crashes, it will not affect the life of the patient. The control system will still be working, and that control system is not affected by fancy electronics. In case the pressure sensor does not detect an inspiration by the patient, the inspiration timer will automatically set off, and the expiration timer will also automatically set off. After that, once the timer of the expiration sets off, the exhaust valve will open, and the air will go through the pressure regulator, that's the third water column. This is going to give the PEEP pressure. So if you set it at 40 centimeters of H2O, you're going to have a 40 centimeter PEEP pressure. All excess pressure will be vented in the room through an HEPA filter to prevent contamination. Since this is the second HEPA filter on the line, it acts as a redundancy of the system to really prevent contamination.